In this video, we'll be learning how to solve quadratic equations, specifically trinomials, by using the ABC values and having an A value that is not 1. So when we factor trinomials, the three most important values that help us to factor that trinomial are A, B, and C. And remember, A is the coefficient of the x squared here, B is the coefficient of x, and C is a constant all by itself. Now, in previous videos, we have seen that when A is equal to 1, the factoring process is pretty simple. You can get to your factored form fairly easily by looking at those values of A, B, and C. In this video, however, we're going to focus on when A is not 1, and that means that this process is going to take a little bit longer because factoring when A is not 1 is just a little bit more challenging. So let's dive on in with an example. To start, we need to identify our A, B, and C values. So that's our first step. We're going to look at A, B, and C. A, remember, is our coefficient of x squared, which is 2. B is our coefficient of x, which in this case is a -5. And C is our constant value, which is a -12. And what we're going to do to start is we're going to look for two numbers that multiply to whatever A times C is, which in this case is 2 times -12, which is -24. And then I need those same two numbers to add to B, which is -5. So I'm looking for two numbers that multiply to -24 and then add to -5. And when I start to think through the factors of -24, I learn that 8 times -3 gives me 24, this -24 here. And then -8 plus 3 gives me this -5. So what I'm going to do is I'm going to take this middle number here and I'm going to rewrite it using -8 and 3. So if I go down to my next step here, notice I'm going to leave the 2x squared and the -12. Those I'm not going to change. But this -5x I'm going to write as -8x plus 3x. Notice that technically I wrote -5x, but I wrote it using an addition problem with two terms, because -8x plus 3x gives me this -5x here. So once I've split that -5 up, which is our third step here, I'm then going to factor by grouping and split these up into pairs. So I'm going to look for the greatest common factor within each pair here. So if I look for the greatest common factor between 2x squared and -8x, I know that the number they have in common that's the largest is 2, and then they each have at least 1x. So if I factor out a 2x out in front, I find I have 2 divided by 2 is just 1, so I can put the 1 there or not. X squared over x leaves me with 1x, and then -8 divided by 2 is -4, and the x's cancel. So now as I factor a greatest common factor out of this second pair, what I'm trying to do is I'm trying to make the parenthesis part match that x minus 4 piece. So between 3x and -12, I can see that they're both divisible by 3. And then they don't have the same variable, so there's no variable to cancel out. 3 over 3 leaves me with 1x, and then -12 divided by 3 is a -4. And so now what I see is I can see here in step 4 that I have parenthesis parts that match. I can see that there's a 1x minus 4 and a 1x minus 4. That's what should be happening if you're factoring that trinomial correctly. Because what we can do is we can say that both 2x and 3, both of those two values, are being multiplied by the 1x or just x minus 4. So we can see here we have our big distribution, 2x times this whole parenthesis, 3 times this whole parenthesis. And so there's my final factored form. I can see that I basically undid the distributive property here, unmultiplied these. And if you're unsure if your factored form is correct, you can always multiply it back out and it should take you right back to where you started. So let's take a look at a second example here. So again, I need to start by finding A, which in this case is a -1, B, which I can see is a negative 12, and c, which is negative 27. And I'm going to start by finding two numbers that multiply to a times c, which in this case is negative 1 times negative 27, which is a positive 27. And then I need two numbers that add to b, which in this case is a negative 12. So if I start thinking through the factors of 27, what I find is that the two numbers that multiply to 27 but add to negative 12 are negative 9 and negative 3. Those two numbers when multiplied give me a positive, but when added give me a negative. So what I'm going to do here is I'm going to rewrite this middle term using these two magic values of negative 9 and 3 here. So we have negative 1x squared minus 9x minus 3x minus 27. And there are two ways that we can really go about this. Whether you factor out a positive or a negative with the greatest common factor will be up to you. But we're going to, again, look at this in pairs and find the greatest common factor. And because I'm seeing so many negatives, I'm going to factor out a greatest common factor that's negative. If you did it positive, you'd get a slightly different but similar answer. But for this, I'm going to factor out the negative. So here I can see negative 1, negative 9, the largest number they both have is a negative 1. And they each have at least 1x. So if I factor out negative 1x, negative 1 over negative 1 leaves me with a positive 1. X squared over x leaves me with x. Negative 9 over a negative 1 is a positive 9, and then the x's cancel. Now my goal with this second greatest common factor is to get it to match this parenthesis part here. And the easiest way to do that is by factoring out a negative again. So negative 3 and negative 27, their greatest common factor is going to be negative 3. Then negative 3 over negative 3 gives me a positive 1 with an x remaining. And negative 27 over negative 3 gives me a positive 9. So from here, you can see that we now have matching parenthesis parts. So we can group these beginning pieces together here. And we end up with negative 1x minus 3 times 1x plus 9. Now, if you had factored out positive numbers here, you would have gotten a slightly different answer. Your answer would have looked like 1x plus 3 and negative 1x minus 9. It just kind of flips the negatives around. It doesn't matter which one of these you have. It just matters that you are consistent with how you do it. So you should end up with one of these two answers, which, if you multiply them out, will take you right back to where you started. So now let's try to use this factoring strategy to help us solve a polynomial equation. So here you can see that we have an equation, and it's got the equal sign in there. And our goal here is to use factoring to help us out. So we're going to use the zero product property. And remember, to use the zero product property, the first thing that you need to have in order to use this is you need to have it equal to 0, which we can see in this case we already have. So we have this requirement, the 0 requirement, of the zero product property. But now we need to turn this into a product. And we turn things into a product by using factoring. And here, because I have three terms, you can see there's three different terms there that can't be combined, we're going to use those a, b, and c values to help us out. So here I have an a value equal to 4, a b value equal to negative 12, and a c value that is equal to negative 7. So we need to start by finding two numbers that multiply to a times c, which, if we see here, is 4 times negative 7, which is negative 28. And then I need two numbers that also add to b, which is negative 12. So when I start thinking of numbers that multiply to negative 28 but add to 12, I'm realizing that to get this negative product, I have to have one negative and one positive. And as I start to think of things that multiply to negative 28, I discover that negative 14 times 2 gives me a negative 28, but negative 14 plus 2 gives me a negative 12. So I'm going to rewrite this middle term here as negative 14x plus 2x. And notice that I leave the 4x squared and the 7 the same on the left-hand side. So now we're going to factor this, and we do this by breaking this into pairs and finding the greatest common factor. So 4x squared minus 14x, they're each divisible, the biggest number, by 2. They each have at least 1x. So I factor out 2x, 4 divided by 2 leaves me with 2. Then there's 1x left on the inside. Negative 14 divided by 2 is negative 7. And the x's cancel. Now remember, our goal is always to get a matching parenthesis part. So as we look at this second pair over here, you might be wondering what we're actually going to factor out, because 2 and 7 don't have a common factor other than 1, and they don't have a variable in common. Well, in this case, because that's the parenthesis part we're trying to get, we're just going to factor out a positive 1. And if we factor out a positive 1, 2 over 1 is 2, the x stays, and then negative 7 over 1 is a negative 7. So now from here, we have matching parenthesis parts, which we can see. So we can group the 2x and the 1 together out in front, and we have 2x plus 1, both being multiplied by 2x minus 7. Now, if we were just factoring, this is where we would stop, but because we have an equal sign on an equation we're trying to solve, we're now going to break this up, because we have something times something equals 0. So we have the zero product property ready to go, which means we can set each little mini equation. So we have 2x plus 1 equals 0. We have 2x minus 7 equals 0. So we can now solve each little mini equation here. Subtract 1, divide by 2. So we have x is equal to negative 1/2. And then we add 7, divide by 2, and we have x is equal to 7 over 2. So both of these equations, if we put them back into that original equation up there, will make this equation true. So let's solve one final example here. So this polynomial equation is a little bit more challenging because we don't have the 0 part of the zero product property. So if we want to use the zero product property in factoring to help us solve this, we have to rewrite this so it's set equal to 0 first. So we need to start by subtracting 4 from each side and subtracting that 2x from each side. And as we do so, we end up with 6x squared minus 1x minus 2 is equal to 0. So we start off by setting it equal to 0, so we have the 0 part of the zero product property. Now we're going to flip this around and turn this into a product. And remember, we can turn things into a product by using factoring. So that's what we're going to do here. So we're going to use our a, b, and c values to help us out here. So we have a is equal to 6, b is equal to negative 1, and c is equal to negative 2. And so we're going to start by finding two numbers that multiply to a times c, which in this case is 6 times negative 2, which is negative 12. And then those same two numbers have to add to b, which is negative 1. So I see here that I need two numbers that multiply to negative 12 but add to negative 1. That means I'll have one positive and one negative. And when I start thinking about those factors, I realize that negative 4 times 3 gives me 12, or a negative 12. And then negative 4 plus 3 gives me a negative 1. So now I'm going to take this middle term here, and I'm going to rewrite it slightly differently. So we have 6x squared we're leaving alone, but then this becomes minus 4x plus 3x minus 2 is equal to 0. So now we're going to break this up into pairs and find the greatest common factor. This first pair, they're both divisible by 2 and contain 1x. 6 divided by 2 is 3, and then there's 1x left. Negative 4 divided by 2 is negative 2, and the x's cancel. Then if I look at the second pair, I see that their greatest common factor is 1, so that's all I'm going to factor out there. And so we have 3x, 3 divided by 1 is 3, and the x stays, and then negative 2 divided by 1 is negative 2. So from here, we are almost done factoring. We just need to group those front values together because they're both being multiplied by the same parenthesis piece. So we have 2x plus 1 times 3x minus 2 is equal to 0. And now we have the 0 part as well as the product part, where we have something times something is equaling that 0. So now we can just set each little mini equation equal to 0 and solve. So if we set each equal to 0, subtract 1 here, divided by 2. So we have x is equal to negative 1/2. And then here we add 2 to each side, divide by 3. And our other value is that x is equal to 2/3. So both of these values, if we take them, we put them all the way back up here into the original equation, they will make the original equation true.